Most security and IT teams live with a strange tension. You are sitting on a growing pile of sensitive data, and at the same time, you know that a single careless copy, export, or test database could turn into the next incident. Developers want realistic data to debug real bugs. Analysts want rich history to answer hard questions. Business teams want to share examples with vendors and partners. Early on, this insight for Bare Metal Cyber Magazine's Tuesday Insights feature focuses on that tension and on one set of tools that can ease it: data masking and anonymization.
At a simple level, data masking and anonymization are ways to change sensitive values so they stop pointing cleanly back to real people while keeping the data useful for work. Instead of a real name, you might use a fake but realistic one. Instead of an exact address, you might keep only the city and state. Sometimes you replace identifiers with tokens. Sometimes you shuffle values. Sometimes you aggregate up a level so details blur together. These are not single products. They are patterns that live in your data and analytics layers, between raw sources and the people and systems that consume them.
It helps to separate these techniques from other familiar controls. Encryption is about protecting data at rest or in transit so that only someone with the right keys can see the original value. Once decrypted, the raw data is back. Masking and anonymization change the value itself before it leaves a defined boundary, so there is no real version in the hands of most users. Access control is about deciding who can see a record. Anonymization changes the record, so that even if more people see it, it no longer easily reveals who it belongs to. That is why simply stripping names while leaving unique IDs and detailed timestamps is not enough to claim true anonymization.
Behind the scenes, these approaches depend on a few basic building blocks. First, you need to know which fields and data sources are sensitive. That usually means some level of data discovery or classification, tagging things like names, email addresses, card numbers, identity numbers, and free text fields that might contain personal details. Then you define rules for each type of sensitive field. You might decide to mask card numbers, but keep the last 4 digits, to replace emails with non-routable addresses, or to aggregate precise locations into broader regions. Those rules become policy, not one-off scripts. Once the rules are in place, they have to be wired into the places where data moves. One common pattern is a masking step between a production database and a test environment. As data is copied, selected columns are transformed according to the rules. A more advanced pattern is dynamic masking, where the data platform rewrites certain fields on the fly depending on who is querying. A production support engineer working a live incident might see original values, while a developer or analyst looking at the same table sees realistic but fake stand-ins. Logging and audit trails show when and how masking was applied, so you can prove the behavior later.
A concrete example makes this easier to picture. Imagine a customer table with names, emails, addresses, and order history. For a test environment, you still want real relationships between customers, orders, and products, but you do not want real people exposed. A masking pipeline copies the table structure and core behavior, then transforms values. Names are replaced with random but plausible ones. Emails are rewritten to a fake domain. Addresses are trimmed to city and state. Direct identifiers are replaced with tokens that still let you track behavior in that environment. If that test database escapes into a less controlled space, it is far less likely to expose actual customers.
In day-to-day work, the most visible impact is on non-production environments. Developers and testers often want data that feels like production, so they can reproduce tricky bugs and see real edge cases. Without masking, the default answer is to clone production and hope no one loses a copy. With masking in place, the team keeps realistic distributions and data shapes while cutting the direct link back to real people. The developer sees that an order with a certain pattern fails, but they never need to know that the person behind it is a real customer with a real email address.
Analytics and reporting are another frequent use case.
Business analysts, finance teams, and operations staff often work in big data warehouses or data lakes. Giving all of them raw access to identifiable records is both risky and unnecessary. Many organizations instead build masked or anonymized datasets tuned to common questions. Age bands replace exact birth dates. City-level location replaces full addresses. Tokenized customer identifiers still allow measurement over time. A simple starting point is to ensure that any export feeding spreadsheets or ad hoc analytics tools passes through basic masking rules, cutting down the chance that a stray file in email or a shared drive reveals too much.
There are also deeper patterns where masking and anonymization are part of a broader privacy-aware data strategy. In these environments, data teams design standard anonymized datasets for machine learning, apply dynamic masking in shared data platforms, and build aggregations that allow cross-region analytics without moving raw personal data across boundaries. At that point, masking and anonymization are baked into how the business designs and delivers data products. The reward is the ability to run richer analysis, enable self-service for more teams, and still respect regulatory and contractual boundaries.
When these techniques are implemented well, they deliver very real benefits. Work that used to be blocked behind special access can move ahead using safer data. Developers move faster because they have realistic environments. Analysts gain freedom without increasing risk to individuals. Some systems or processes can be deliberately kept out of the strictest regulatory scope because they never handle identifiable information at all, thanks to masking upstream. For leaders, this can feel like finally aligning innovation and privacy instead of choosing one over the other.
None of this is free. Masking and anonymization add moving parts to your data pipelines. Rules have to be defined, tested, and updated as schemas change. Someone needs to watch for drift and mistakes because a single new column can quietly reintroduce sensitive information. More advanced techniques, such as strong anonymization or dynamic masking in complex platforms, often demand both specific product capabilities and people who understand data privacy patterns. Organizations that lack basic data classification or centralized logging often find themselves wrestling with those foundational problems before masking truly works.
There are also hard limits you cannot wish away. Very detailed datasets with many attributes can be difficult to anonymize in a way that still leaves them useful. Simple masking and basic generalization can be vulnerable to re-identification when combined with other information, especially in small or highly specific populations. Some tasks, like fraud investigations or certain incident response activities, legitimately require access to original values. In those cases, masking and anonymization support a tiered access model instead of replacing sensitive data entirely. A mature design acknowledges that some people, in some tightly controlled contexts, will still see the real thing.
Where things go wrong, it often starts quietly. One common failure is the mask once and forget pattern. A team builds a masking script for a test database during an early project, but never updates it. Over time, that database grows new columns and new tables with sensitive data that the original script does not touch. Everyone keeps talking as if the test environment is masked, even though that stopped being true long ago. A similar pattern appears when teams only mask obvious fields like names and card numbers, while leaving log messages and free text fields untouched, even though those places often carry personal details, secrets, or support notes. Shallow adoption also shows up in everyday behavior. When developers keep asking for raw production copies because masked environments are broken or do not behave realistically, it is a sign that the controls are getting in the way of actual work. When analysts are encouraged to grab full raw exports just this once for urgent requests, that exception quickly becomes the norm. You may see people keeping local unmasked copies on laptops or shared drives because official anonymized datasets are hard to access or too limited. On paper, masking exists. In practice, people bypass it whenever they feel pressure.
Healthy patterns look and feel different. There is clear ownership for data classification and for the rules that govern masking and anonymization. Non-production environments behave realistically enough that requests for real production data stand out as rare exceptions, not standard procedure. New projects and integrations include questions about how data will be masked or anonymized as part of their normal design conversations. Logs and audits show masking being applied consistently as data flows. Over time, incidents involving lost test databases, stray exports, or abandoned spreadsheets become less frequent because more of the data moving around is already safer by design.
At its heart, data masking and anonymization are about giving teams the data they need to build, test, and understand systems without turning every copy into a potential privacy incident. These techniques live in your data and analytics layers, shaping what leaves your core systems and how safely it can be used elsewhere. They work best when you pair them with solid data classification, realistic understanding of your limits, and culture that treats safer data as the default, not the exception.
As you look around your own environment, pay attention to where sensitive data travels, who really needs to see raw identifiers, and where safer stand-ins would be good enough. Each test database, export, or shared dataset is a candidate for masking or anonymization. The more you can rely on these patterns by default, the fewer surprises you are likely to face when a forgotten copy shows up where it should not.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.